This question asks us to find the scalar product of the vectors 2i minus 3j plus k. Well, the first thing that we have to realize is that this is plus 1k and I plus j minus k. This is 1i, 1j, and 1k. Of course, we know that the scalar product or the dot product A times B, or A dot B, is the magnitude of A times the magnitude of B times cosine theta. We could find this using Pythagorean theorem, find this using Pythagorean theorem using our 2, negative 3, 1, and 1, 1, negative 1, and then we could draw it, use the distance formula, and then the cosine rule to find theta. Or we could simply use this. This is the second one we have to remember, which is a lot easier. I'm going to choose to use this one, and watch how easy this becomes. It's x1 times x2. 2 times 1 plus y1 times y2, negative 3 times 1 plus 1 times negative 1. 1 times negative 1, which gives me 2 minus 3 minus 1, which is equal to negative 2. And there is my answer. For the following vectors, find their magnitudes and scalar products. Hence, find the angles between the vectors. Well, we have 0i plus negative 5j plus 4k and negative 5i plus negative 1j plus negative 3k. You could write that either way. You might see it like this, or you might see it drawn out. Well, what is their magnitude? We have to use the Pythagorean theorem. 0 squared plus negative 5 squared plus 4 squared square root is equal to the square root of 41. Negative 5 squared plus negative 1 squared plus negative 3 squared square root is equal to the square root of 35. We found the magnitude of vector A and the magnitude of vector B. I just randomly called that one vector A and that one vector B. The scalar product, we know A dot B is x1, x2 plus y1, y2 plus z1, z2. I went this times this plus this times this plus this times this, add them up, and I get the dot product is A dot B is negative 7. So we just found that the magnitude of A was the square root of 41 by Pythagorean theorem, the magnitude of B was the square root of 35, and our dot product was negative 7. Now we can find the angles between the vectors using A dot B is magnitude of A times magnitude of B times cosine of the angle between them. Divide both sides by the magnitude of A times the magnitude of B, and I get this statement here. Now I just have to substitute negative 7 for my numerator, the square root of 41 times the square root of 35. When I do that, I got a statement saying cosine theta. Well, we know that theta, if I come up here, from there up here, I know that theta is cosine negative 1, or we call arc cosine of negative 7 divided by the square root of 41 times the square root of 35. When I punch this in my calculator, I get theta is equal to about 101 degrees with 3 significant figures. Find the values of m for which the vectors 2mi, so our sort of coefficient there is 2m, plus m, that's 1mj, plus 8k, and their second vector I plus 3m, that's taken as 1 unit, j, minus 1k are perpendicular. Well, what do we know? Here's the key to the problem. If vectors are perpendicular, then their dot product is the magnitude of A times the magnitude of B times cosine of the angle between them. If the angle between them is 90 degrees, cosine of 90, think about the unit circle at the top. Pi over 2 cosine is 0. So our dot product will be 0 as well, because cosine 90 goes to 0. So we know this is the key information for perpendicular vectors. Well, that means that A dot B is x1, x2 plus y1, y2 plus z1, z2, and that is going to equal 0. So all I had to do was replace x1 with 2m, and x2 with 1, y1 with m, and y2 with 3m, and z1 with 8, and z2 with negative 1. When I do that, I know that this is going to equal 0, and I get 3m squared from my middle term plus 2m minus 8 is equal to 0. And we're back with the basic algebra problem. I can factor this equal to 0 with 3m minus 4 and m plus 2. So I know my answers are, I set both of those equal to 0. If I have 3m minus 4 equals 0, then m is going to equal, add the 4, divide by 3, 4 over 3. And if I have m plus 2 equals 0, I'm going to subtract 2 from both sides and get m is equal to negative 2. Here are the possible values for m. Find a vector perpendicular to u, which equals 4i minus 3j. Well, that's the question here. We've got to find a vector that's perpendicular to u. Well, what do we know about perpendicular vectors? Their dot product, a dot b, is the magnitude of a times the magnitude of b times the cosine of the angle between them. If they're perpendicular, then they have that little box there. It's 90 degrees. Cosine 90 is 0, so our dot product is 0. That's the key bit of information. A dot b equals 0. Well, here's our first vector, which will be 4 and a negative 3. I don't know my second vector, v. So this is where I made it up. I say it's x and y, xi plus yj. Well, if that's the case, then I know I can find x1, x2 plus y1, y2. And that will give me 4 times x plus negative 3 times y, which we can write as negative 3y. And I know that that is going to equal 0. Again, this vector, the 4 and the negative 3 components were given to me. I don't know what my perpendicular vector will be, so I just call it x and y. But I do know their dot product will equal 0, and when I dot product them up, it's just 4 times x and negative 3 times y, and add them up. Well, also, I do know that if v is perpendicular to u, then the unit vector of v is also perpendicular because v and its unit vector are both in the same direction. That's a key piece of information. If v is going this way, then v hat, its unit vector, is going the same way. So if v is perpendicular to u, then v hat will be too. Well, what is the magnitude of v hat? Magnitude of v hat is 1. And we know that we can find, if I have v hat going this way, I know its x component is just simply x, and its y component is simply y. So I can use the Pythagorean theorem to find the magnitude of v hat, which I know is 1 because by definition it's a unit vector, will be x squared plus y squared square root. So now I've got this equation and this equation. If we know from our last slide that we had u is equal to 4i minus 3j and v is some xi plus yj, we found out that this, when our dot product gave us this, and our definition of the unit vector gave us this. Well, we can take this first equation, which I'll call 1, and solve for y. Minus 4x to both sides, then divide by negative 3, and we get y is equal to 4 over 3x. Well, we can take that and substitute that into equation 2, which I wrote here. If we substitute for y, we get x squared plus 4 over 3x squared. That whole thing squared gives you 16 over 9x squared. And we can convert 1x squared to 9 over 9x squared plus the 16 over 9 gives us 25 over 9x squared equals 1. Multiply both sides by the reciprocal, we get x squared equals 9 over 25. And then I take the square root of both sides, I get plus or minus the square root of 9 over 25, which is plus or minus 3 over 5. That allows us to go back over here. Well, y is equal to 4 over 3 times 3 over 5, or y is equal to 4 over 3 times negative 3 over 5. Either way, I'm going to wind up with y is equal to, from these two, I'll get y is equal to plus or minus 4 over 5 for my final answer. So I know that my x is plus or minus 3 over 5, and my y is plus or minus 4 over 5. Well, I was looking for this. Ultimately, I want to find v. V will be plus or minus 3 over 5 I plus or minus 4 over 5j. And that is my final answer. That's a hard problem.